Okay, continuing on with our Hyperion project. In this video, what I would like for us to do is get the framework in place for every method that we have commented in for our objects. What am I talking about? Remember, as we came along in the very beginning and we created all of our different classes, right? And then inside each class, we dropped in some comment bars here, and we just gave the name of the action for that method that we wanted the object to be able to do. So in this case, we wanted our player object to be able to move, to be able to pick up items, drop items, etc. And all of these guys, or almost all of them, have their own methods. Like the game manager is going to be able to start a game, end the game, apply rules, etc. Well, these are just comment lines. We haven't actually set up the structure of that method. Take a look at this. Here is a method that has got a structure set up and code inside of it. Also, if we were to come over here to program, here we go again. The main method, our entry point. Also, structure is set up and there's some code inside the structure. So I want to talk a little bit about that. But first, before we do that, we introduced a small, very small typo in the last video, didn't we, Logan?
Yes, we missed, well, I got a little bit too happy with the copy and paste when I was going through properties.
And when you do a lot of copying and pasting, that can bite you in the butt. It really bit Zach when he came through and wrote the level out for Hyperion. He did a whole lot of copying and pasting from room descriptions and all. And I'll tell you what, he spent quite a bit of time debugging because he just left stuff all over the place that didn't need to be there. But it also bit us here in the coding process. One of the things that I'd really like for us to try to get into a habit of doing is compiling or building our solution after each of these videos or at the end of the video, just to make sure that we don't have any typos that we may have missed. So if you guys were following along very carefully, there's a very good chance that you caught the problem. But if not, check this out. What I want to do is go ahead and come up here to build and build the solution real quick. Or we could try to just play it or run it. Either way, it's going to let us know that, click, we have two errors. We cannot implicitly convert type int to string, and we cannot convert type string to int. So with this, check it out. You can come over here. You can see what file it's in, item.cs. Well, that's in our item class. You can see what line it's on, what column, and of course what project, in case we're working on multiple projects at the same time. But let me double click this. It'll jump me right into the item.cs file, and it comes all the way down here to the bottom, and it highlights this weight right here. All right, let's take just a second and take a look at what's going on. We are inside this property structure right here, public string weight. There's the capital W, and remember we said that we made all of our property names begin with a capital letter, and then these properties in almost every case throughout our application here are related to a particular variable that they're going to be working with. Well, the variable in this case is weight with a small w. The property name is weight with a large W. Now, let's take a look at the type that weight is, the variable weight. So if we scroll up at the to the top, we'll see that we have private int weight. So weight is an integer, and that makes sense because we need to be able to store numbers in it. Now, let's go ahead and scroll down and see what our problem is. Aha, we have a string type property. And that they just don't work together because remember what a string is? It's alphanumeric stuff. It's just text, okay? And an int, well, that's numbers, 1, 2, 3, etc. So whole numbers, alphanumeric text, different types, cannot implicitly convert from our whole numbers over to our alphanumeric text. And of course there's ways to convert, but we'll talk about casting and all that good stuff later. In this particular case, we need our property type to match our variable type because these two are working together. Very important. Super easy to fix. All we need to do is come in here and highlight this and change it to an int. That's it. So now if I come through and build, what's going to happen is I'm going to see a whole bunch of warnings but no errors. So build solution. Look at that. All of our errors went away. Now we've got 4 warnings. It's not a problem right now. It's just telling us things like the private field hyperion.player.inventory items is never used. Well, of course not. We're not done programming our application yet. But we have no errors, which means if we wanted to, we could come back up here and run our little application, and you can see we get our title screen, Welcome to Hyperion, and everything is just fine. Let's go ahead and close that. And now let's go ahead and bring our attention back to methods. So almost all of these different classes have methods laid out in them. Of course, right now they are simply in the form of comments. Well, what I want to do first is jump over to the whiteboard and talk just a little bit about methods, because as Logan goes through here and sets up the structure or the framework for each of these methods, I want you guys to have a little bit of an idea of what's going on. So, here we are, the whiteboard. Now, the first thing I want to do is write out the syntax for a method, and there's a lot of stuff to write here, so let me scratch my head for a second as I think about maybe moving some stuff around. Like I can move this down just a little bit. That'll work. So I can start all the way over here. Now, the first thing, I know, let's make this look really interesting. First thing I'm going to do is say optional modifiers. Interesting start, huh, Logan?
Yeah, it's symbols and stuff.
Now we're going to come in here with a required return type. And we'll close off that. Okay, now what we need is a method name. So exciting, so much to write. Alright, now what I'm going to do is put an opening parentheses, and inside here I'm going to do another, and technically this is optional, but if you're going to have a parameter, it's required, so
that it has a type.
That it has a type, so I'm going to go ahead and tell it param type. Go ahead and close that. And if we have a parameter, we have a parameter name. Okay, and then we can close that. We're going to have a comma. Then I'm just going to do a dot, 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 because we can have a whole bunch of those if we want. And then I'm going to close my parentheses. Then I'm going to drop down here and I'm going to have an open curly brace. And I'm going to have a closing curly brace as that jumps over just a little bit. And in here, I will add a return, and this isn't always going to be here. I'll just say that up front. So return, and with return, of course, we are required to have some sort of return value.
The upshot of this otherwise scary looking diagram is once you understand it, methods themselves should be easy.
Yeah, no kidding. Alright, nice and scary. Oh, man. Well, you guys have actually been looking at this kind of stuff. So let's get a real close look. We've got modifiers, return type, method name, and then in opening and closing parentheses, a parameter type, parameter name, comma, and we can continue having parameter types and parameter names. Before I start drawing all this out, let's jump back over real quick into Hyperion. So we'll come down here and take a look at an example. So just real quickly coming over here actually to the game manager. So the game manager, we have already created one method and set its framework up, and here it is. Check it out. Public static. Two modifiers that we are using. Next, return type, void. Next, show title screen. Open, closing, nothing inside. Now we have an opening curly brace, closing curly brace, and between them our code that's going to be executed for that method. Same rules apply again. So let's go over here to program. Programs, here we are with yet another method, our main method. A single modifier this time, static. Our return type is void. Our method name, our opening parentheses, a parameter type, the parameter name. There you go. So, and again, an opening and a closing curly brace with our code for that particular method between the two. So there you go. It's that simple. Now let's go ahead and jump back over to the whiteboard and see if we can talk about this a little bit more. It's really laid out in a simple way. We've already talked just a tad bit about types. We know we have types like integers, and those are going to be things like 1, 3, 6, or whole numbers. We have things like strings, and this is going to be stuff like high, 6t, etc. There's all sorts of different types, right? Now, what we're going to end up finding ourselves having to do when creating methods is work with types, because methods are going to quite often take types of data in, do work with that, and then send data back. You can think of a method as kind of like a black box. So here is a black box. Now, we have the ability to simply call on this black box to do something, and then it'll do something. Very, very straightforward method, and with that, we don't have to send anything. As a matter of fact, back in Hyperion, did we have, our show title screen didn't take anything in.
Right.
I'm just going to jump back and forth between these if you guys don't mind, because I'd really like to point this out. So back over here in the game manager, here we go. So we have a void, so we're not sending anything back. Show title screen is the method name, and look at that, just open, closing. So in this particular case, we are simply calling on this method to do something, okay? Now let's jump back over here. Sometimes we'll be in situations where we might call on a black box and send it some information. Okay, so here's some information, and this information coming in, it's called an argument when we're passing the data from outside. And you've seen this before, command line arguments. You know, if you're at a console and you're going to type an application and then you feed it additional arguments. So most everyone has heard of that at one point or another without even being exposed to the programming world. So this is known as an argument. But when this information gets into our method, it needs to be stored in here. And once it's stored in here, that information is being stored in a parameter. Just so that we get all of our naming conventions or naming terminology correct here. Go ahead.
Right, it all depends on what side of the method you are on. If you are on the inside, you look at the values as parameters, the names that you work with.
Precisely.
If you are on the outside of the method, you look at the data that you're sending it as arguments.
That's right. So if we were to jump again back over into Hyperion and come up here to the program class, when we run this application, so we can actually go out to a console, like a DOS window, and jump into the right folder where we have access to Hyperion.exe, and we can run it, and if we wanted to, we could actually send in information. We can send arguments into it, and those arguments would then be stored in this highlighted parameter. And the parameter right here, it's saying, look, we're expecting a string array in, and we're going to store it in the parameter name args. That is the parameter name. So again, when we call upon our method, we're going to call the method and send it arguments if it requires arguments. And then on the inside of that black box or inside of the method, we're going to store the information we sent in inside of parameters. So there you go, a little bit of terminology. So let's jump back over here. From time to time, we're going to find ourselves having black boxes that will do some work inside here, so some sort of work, and send information back out. This is where we are returning information. You're going to see return pop up a lot. In sending information back out, we need to know what type it is. So type's going to become important all over the place. And that is why if you look up here, all the way back into the syntax, you'll notice that for returning information, we have to tell it the return type if it is returning anything. And over here, taking information in, we have to tell it what kind of information is coming in. So back down here to this example right here, if I was sending an int in, so a number is being sent in, this parameter right here, it better be of type int. Otherwise, we'll have another mismatch and we'll have a problem. Now, there's all sorts of neat, fancy things we can do later in regards to parameters and all. I'm trying to be very careful.
You're trying to be careful with the keyword versus the terminology.
Yeah, there's... I'll just leave it at that. So for anyone who's watching this who is a bit more of a skilled programmer and they are familiar with methods and let's just leave it with methods and parameters. There's all sorts of interesting things that we can discuss right now, but I'm trying to keep this the scope very focused. So here we are, 3 different examples. One, we have nothing at all being sent in, this guy right here. This guy right here is taking an argument in. This guy down here is returning information back. Now, we can also, of course, define these where we send multiple arguments in. And if I send multiple arguments in, so here comes another piece of information, another argument. Inside, I better have a second parameter set up to take that information in. If I was to send in a third argument, I better have 3 parameters set up to deal with them. So in other words, however much data you're planning on sending in, separate pieces of data, okay, different arguments, you better have that many parameters set up inside. Otherwise, you're going to have a problem. Now, down here with the return, we're only going to return one thing out. Okay, it's not like we have 15 different parameters that we can send out of it. It's not like that. It is just simply a return value. That is all. Keep that in mind. And I can also mix and match these things. I can say, let's send in 2 pieces of information. So here comes 2 arguments in. Internally inside the method, they are expecting 2 parameters. Do some work and send some information back out. So this right here, this arrow is not... It's just trying to say, look, we've got information going along our return line. So there you go. That is a very, very basic look. So, I mean, I could come up here and say, I wanted to do something like public. So that's my modifier. And void. Ooh, void. I'm not going to return anything. So I type void because it's required. And then I'm going to say, let's see, my time. Actually, I don't want to do that. And you know why? Because I'm going to really be a good boy. And I'm going to stick with everything we've been saying. It's a method, so it's got to be a verb. I'm going to say get time. How do you like that, Logan?
Is that something that you would tell it to do?
To do, that's right.
We're assuming that it has to go out, find the time value, and then do something with it.
Now, in this particular case, I'm doing an open and a closing parentheses with nothing inside because I'm not passing any arguments to it. Then I'm going to come over here and do an open curly brace, a closed curly brace, and inside here, I'm going to print out the current time. Get time. Now, if I wanted to, I could restructure this so that instead of void, I could basically take a date time back. And then we would, in here at the very end, we would be returning a date time. But in this case, since I've got void set up here, the only thing we can really do of value here would be in this line right here, just add a line of code that simply prints out to the screen what the current time is. Okay? So this is, I know for those of you that are new to programming, I'm going to keep reminding you of this. This may look a bit scary, but just breathe deep, follow along. What I want to do, Logan, if you don't mind, is add another class to Hyperion. Let's make the cheapest calculator in the world, if you don't mind. As a matter of fact, before we do that, let me go ahead and come over here and add, let me do just a little bit more writing. So I'm going to add another one of these and come over here and take this guy just so I can deal with erasing. I'm going to switch these and come up here. Let's create a class that is going to serve as a very, very cheap calculator. Very cheap. It's not going to do much. So it's going to be an object. Be a calculator, and I want to give it just a few functions internally. The whole time thing. How about we do that? How about we have a function inside, or a method, excuse me, called display time.
It's the world's simplest advanced calculator because it has a clock in it.
That's right. Then let's say that it has the ability to find the square root. So find... I'll just do SQR root. And to demonstrate sending a piece of information, let's go ahead and send it an integer. And we'll just call that parameter num. Something like that will work. Let's do something that returns something. I know. Let's do is even. So is even. And with is even, let's again send it something. But check it out. Let's have it send back to us a true or false. So that is a boolean. So is it true or is it false? Yes or no? And finally, let's do one more that is going to be called something like add numbers. And add numbers, let's go ahead and take in 2, just to demonstrate actually sending 2 arguments into this method. So we'll say int num a, comma, int num b. Close. And how about let's have add numbers, take in a and b, add them together, and return it back, and we can do with it whatever we'd like with whoever called it, basically. So let's put this together right here, okay? Very simple, straightforward, and I think it demonstrates most of the combinations in the most simplistic form. So hopping on over into Hyperion.
All right, we're going to jump back into the code, and like we were talking about, we're going to add a new and sort of temporary class to our project. And as a matter of fact, I'm not even going to add it to the classes just because we're going to delete it later. I'm actually going to add it back up at the project level so it will reside in the same level as program.
Okay.
So I'll just grab the Hyperion project. We'll add a new item. That will be a class, and this will be our calculator. So the calculator CS file contains the class calculator. We're in the right namespace, so we're ready to begin.
Okay. The first thing in this case, since I don't want to have to create an instance of calculator, let's go ahead and make it static. And as everybody knows, this means we have just one calculator. We can't make multiple calculators. This also means the moment we execute our application, this object exists, just automatically. Okay, so with that in place, the very first one was display time. So let's go ahead and see if we can set that up.
All right, let's begin with some modifiers. This is going to be public because it can be accessed from outside of calculator. It's going to be static because we're inside of a static class. And its return type is going to be void because it doesn't return any data back. It's just meant to do something on its own without any return value.
Right.
And the name is going to be display time.
Okay.
We're going to take in no parameters.
Okay.
So we'll jump down a line, begin on and end our block, and jump inside of our code block.
And that's a good idea for beginners to make sure when you lay all this out, go ahead and do your opening curly brace, put your closing curly brace in there too. It's another thing I see people forget all the time when they're getting into programming.
Right, otherwise you'll get into what it is you're writing, and you'll finish that and you'll forget to put the closing brace on.
And there you go with a problem.
Alright, so inside of display time, like we were talking about, we want to actually write out the time to the console. So I'll have our console.writeLine.
And we've seen console.writeLine before. Now here's something new that you haven't seen. We're going to use another object that is available to us, thank you very much .NET, and because of our using above with using system, we have the ability to just grab the date time. So it is an object, so we can come in here and there's date time, and since it's an object, check it out, we can step down lower and we can grab, well, right now. How nice is that? So now what we're doing basically is saying, let's go ahead and write out to the console the current date time right now. So to take use of this method, we now have it written following the very basic syntax that we set up over on the whiteboard. It takes in no arguments whatsoever. It returns no information back. It just does the work inside itself as if it was a little black box, and that's it. So to invoke this, let's just head on over real quick to program. And then from here, let's just, we can just do it right after that, right before that. It doesn't matter. Or actually, do it right before that because that'll hold us up.
Okay.
So we can just tell it calculator.
So there's our calculator object.
And then check it out. There we go. Display time. The method now shows up for us. It doesn't take any arguments, so we can just simply open, close, and terminate. That's it. That's us saying when we come into the program, into the main method, program starts, let's talk to that calculator object and let's call on its display time method to do whatever it is the display time method is going to do. Let's go ahead and hit run real quick. And look at that. There we go. It's, April the 14th at 2:56 in the morning. Wow, yeah, it's early. So anyways, it's doing its job. And now what's nice, let's go ahead and close this out. Hit enter or X, it doesn't matter. Let's jump back over to our calculator real quick. Now, calculator it's been set up as public. So what's interesting in this particular case is let's pretend our player needed access to the calculator. Our player can see the calculator because the calculator exists within the Hyperion namespace. Don't let namespaces scare you. It's a giant container. All of these objects are being put within that container, and they can all see each other because they are in the same container, all within Hyperion.
Right. It's the same idea where when we were talking about variables and we had a private variable, we could still see that variable if we were inside of the class that it was private to. Same idea here. We have our classes where we have all of our classes inside of the namespace Hyperion, so all of those classes can see each other.
Exactly. I can prove this real quick. Let's go back over to our program class real quick. And now from inside here, let's go ahead and cut the calculator.displayTime out, and we're going to take it over to the game manager, and let's go ahead and call it in there.
So call it in a way that should not change the output. We'll go into title screen and have the display time occur first before the welcome text.
Exactly. So it's going to look exactly the same when we execute the application. And there you go. Now it is a minute later. So everything's working just fine. So with it being public, once again, we can call on this object's method from anywhere in our application, as long as it's within the Hyperion namespace, or if we fully qualify it through the Hyperion dot if we happen to have it.
Is it so much that it's public or that it's just within? It's the you're talking about the fact that the method name itself is public.
That's right. And we are outside of that particular object.
Right, because it's not the calculator itself, it's this method.
Exactly. As a matter of fact, go ahead and change that to private. And we're going to introduce a bit of a problem. And let's go ahead and run it. And, oh, well, there you go. It's inaccessible due to its protection level. There we are, back to security again. So, yeah, that's what I was talking about.
Right, again, exactly like the variable style example. So, because it's now private to calculator, only things within calculator could access this method.
Exactly. So let's go ahead and change that back to public. And then let's jump over to the game manager. And let's cut that out of, because I don't really want to mess with the show title method at the moment. And let's go ahead and run back over to program and paste it back in there right before game manager, since game manager is also in charge of holding us up until we hit a new line. All right, so there we are. We have created our first method. We have, let's go ahead and give me the mouse real quick. Thank you, sir. Let's jump back over here to calculator. And we have created a framework. Now, we've added the code into it. But what we're going to do when we start walking through the entire Hyperion application in just a minute is just put the framework in place. And this is the framework. We've got all the keywords required to define it. Our modifier, what it returns, in this case nothing, the name of the method, any parameters and types that they take, and then the open and closing curly braces. All right, so Logan, that's one. Let's go ahead and continue by adding, what was the next one I had on my whiteboard? I believe it was
the find square.
Is it find square? Okay.
Oh, yeah, find square root.
Let's go ahead and find square.
All right. Again, this is going to be a public method. So we'll have public static void, still not returning anything, and the name of this will be find square root. And this time we're going to take in an argument, or excuse me, a parameter. We'll have the parameter's type be integer. We'll have the parameter name be number. And
now the parameter name, it's up to us to how we want to name it. I mean, there are some rules in there. I mean, we can't have spaces and other things, but that's something we'll talk about at a later date and time. But right now, I just want you guys to know that the parameter name just needs to be something descriptive. Number is descriptive to me. Number to be squared or to find square root of. I mean, it could be whatever. You don't want to go in there and put int hamburger, but int hamburger would work just fine, wouldn't it?
Right, or even something, if you want to make it look more like math notation, int k. That would still be valid. We could use a single letter if we wish.
Absolutely.
But if we were to glance at this code and just look at this portion by itself, what is that? I don't know. Is it some constant from a mathematical formula?
Precisely.
If we do something generic like number,
well, it's
so find square root of the past number. Okay, so it's just a generic number. Very good.
Exactly. Okay, fantastic. So let's make this work, because this is a little more interesting here.
Okay. Find square root of, well, again, the functionality should be similar to display time in that we're going to write directly to the console from within this method. So we have to first access the console and then tell it to write a line. Now, what are we going to write? Well, we need to find the square root of some number, and the easiest way to do that is to call upon the existing math namespace. And inside of math, we have, let's scroll down to the list. We should have square, SQRT, square root. Square root will take in a number. So number, again, this number is the passed parameter. That finishes off the parenthesis for the square root, another parenthesis to finish off for the write line, terminator, and now we should be set.
Check out how cool this is. Really think about it. Here's an object, console. Here is a method, write line, and we are sending write line some data. We're sending it an argument. This is the argument we're sending. But this is interesting. The argument that we're sending is the result of this particular object's method. So we're calling on math square root. So we're basically looking for square root. We're sending it a number. It's going to find it and it's going to return it back. So this is all going to basically result in the square root of the number we sent. And that's what's going to be sent over to write line. Very interesting, huh?
Right. From the outside of a method, you can almost look at it as a type of data. Because if it has a return type, you can just allow it to execute on its own, resolve the expression, and then just in your own mind see it as a number. Because that's what it's going to be in our case. Or even in math. It's square root means some number.
Exactly.
Of course, has to do things inside of it, being a method. But once it's done, we can just look at it as some number, as the result.
Yep. Okay, very cool. So now to test this out, let's go ahead and head back over to program and let's call upon that one. But now what we need to do is send some information. So calculator dot, let's talk to its method. So find square root, open, and now look at that. It's telling us it's expecting an argument. We need to send an argument over there, and that argument must be of type integer. So we could use a variable here, which contained an integer, or we could just explicitly say, do this. So we can send, 16, 9, something like that. And with that, let's go ahead and execute. And there's 4. Very nice. Because remember, we're doing the write line over inside of the method. So that's working fine. 4 times 4 is 16. 16 square root, it's going to give us 4. So 5, that's going to give us something fun. Oh yeah, loads of fun. Okay, so let's go ahead and close that down. So that's square roots. That's sending data to an actual method. Easy enough. Let's go ahead and set up another method that's going to return information back now.
Okay, so let's go back to calculator and let's make that isEven method. So, public, static, and now instead of void, we're going to specify a return type. This will be a boolean, so bool
again, true or false.
Even.
Okay.
Now, isEven is going to take in a parameter. It's going to be an integer number, much like find square root. And after that, I'm going to block in our braces.
Oh, but Logan, this could look really confusing to someone, and I don't want to change it. I want to point this out in case someone's thinking it. You're using int number here, and you're using int number here. Whoa, but you can only do it once. You can't declare it again. Well, this parameter, its scope resides inside of this method. Its scope, it's not seen outside of the method. And same thing here, and that's something we're going to be covering later. So these are 2 completely different parameters.
Right, and like you said, that gets into a discussion on scope as to exactly when things can be seen.
So if you see that, don't panic. Those parameters belong to that method.
Right, and another way to think of it is it exists only as long as you're within the method itself. If you're back over in program, you don't worry about number. You could make your own number inside of program.
That's right.
And it would be different than the number that's inside of find square root, which is also different than the number that is inside of isEven.
Precisely. Okay, so let's see if we can make isEven work. Oh, we get to show something using modulus. Oh, that's great.
And a little bit of branching.
Oh, we're going to do some if.
So we're going to begin an if statement, and we're going to say that if our parameter number modulus 2
that's a percent sign.
Is equal to 0, then we are going to return true. So there's our returning. The type matches our return type. Otherwise, we're going to return false. Again, another value of type bool.
Very nice. Now, what's going on right here with the modulus? This is really simple. The number divisible by 2. What kind of a remainder is left over? Well, if we had a number, let's say we start out with a number of 2. So 2 divided by 2 is what?
Just 1.
Yeah, and what's the remainder?
Nothing. There's no remainder because the division was...
So if we send 2 in as the number, it is indeed equal to 0 because there's no remainder. So it's going to return true. The number is even. So true gets sent back to whoever the caller of this method is. If we sent in 3, well, 2 can go into 3 how many times? Once. So now we say 3 minus 2 is what? And there's 1. So you see what's happening? Now it's going to end up being 1 point something, something, something.
Right, there's going to be a remainder.
There is a remainder. That's the key thing. So if, let's say, if 4 came in here as our number, then what happens? 2 can go into 4 2 times. Any remainder? Nope.
No.
Because it went in there perfect. So it returns back true. So yes, it is even. And we'll spend a great deal of time with modulus later because modulus can be very helpful in a lot of different applications, actually. So right now, that's just the real quick thing is it divisible by this number with a remainder or not? And that determines if it's even or not. Okay? Very cool.
So now I guess we should go back to program and test this. So back to program for a second. We'll start. Now, we can't just say... there's a few things we could do to begin with. We could just try to follow what we've been doing so far. We could say...
See how it blows up?
Calculator dot is even the number 2, and then run.
Yeah, let's try it. And
but we didn't see anything. So, all right, hang on. Maybe it's just hidden. We can't see it because there's so much other stuff. So let's comment out everything except is even.
Okay.
And well, okay, we have to hold up here. So.
Yeah, we do.
We get absolutely nothing aside from the title screen.
Man, it just blew up on us. Method's not working. What's going on?
Well, if we look into it, is even does not write anything out. It's not accessing the console and not writing anything to the console. So as far as the console is concerned, it's completely silent. You won't see anything.
So we've got to do something with this information it's wanting to hand us.
Right, because if we evaluate this, we can think of a Boolean value in place of this expression or method. So we need to do something with it. It would mean that if we're at this level, at the program level, responsible for calling console, and
let's go ahead and tell it right line, and there we go.
And now if we execute, we see the value
true. So is even, and we sent it, what did you send in there? 2. So is even 2? True. So let's change the 2 to a 3. And now let's see, is it even? 3 is false. It's not even. All right, close it out. Put 33 in there. Let's try some bigger numbers. And execute. Nope. Let's try 34, because we know that's even. Blam, it's true. So it is indeed working. So very important. It's not fun having a method blow up on you when you think something's going to happen. Now, in this case, it was very easy to identify because, well, we didn't have any information. But later on, when you have one method calling another method that relies on information from another method, but you don't use that information, well, now you could just cause a chain reaction to make everything blow up.
Or even worse than the program actually exploding is in cases where it just does the wrong thing with no visible error message.
Oh, but Logan, I call that exploding because it not work right. It's not the worky righty. Okay, so now what we need to do is we've taken a look at creating a method where we are sending an argument to it. So, and we're receiving information back from it. So the final example is, let's just show one that does it all. Let's send 2 pieces of data to it and receive something back. And this is going to be the add numbers one.
All right, so let's begin. We've got public, static. This is going to return an integer. And it is called add numbers. Now we have multiple parameters, the first one being an integer called num_a. Now we're going to have a second parameter, so we need to add a comma, then specify the type of our second parameter, and the name of our second parameter, which can be num_b.
Okay.
And then, as we've done before, block in the brackets, and we're ready to do something with num_a and num_b.
The biggest thing right there in this framework that Logan just set up for the add numbers method is the fact that we are taking in 2 arguments. So we've got 2 parameters defined there, and they are separated by commas, but with each parameter you must follow the syntax, the parameter type and then the parameter's name. That's very important.
Right, just to prove that this is in fact working as a framework, we could execute now and... Oh, almost. Okay. There's one thing I want to point out, so I'll come back to this in just a second. The reason it didn't build is we haven't specified a return type, which I guess is another thing to point out. Back in display time and find square root, we didn't have to return.
Right.
At least not explicitly.
Right. And down there when we did the is even, we used that keyword return, so everything was kosher inside of there. There was no problems.
But now we've got a method where we haven't told it what to return, and it's not going to let us build the app, because we've told it that this add numbers can be used in place of an integer, because it returns an integer. So not returning anything would cause a serious problem. So we have to return something. And while we're here, we might as well finish off the functionality and say return num A plus num B, terminator.
So what's going to happen is num A and num B will be added together mathematically and returned to the caller of this method. So who's the caller of the method? Well, let's go back over into our program class and let's set it up real quick.
I'm just going to replace the is even check.
Okay.
Just keep things clean.
Or just copy that whole line, paste it, and comment that out in case anybody's following along.
Sure. All right, so we'll copy, we'll paste in a new version, but comment the is even line.
Okay.
All right, so console.writeLine. That's good. We want to write some value, and we've found that we need to write it out ourselves if we're returning. We need to do something with the value. So let's take a look at add numbers. So add numbers. As a matter of fact, let me completely delete the parentheses out so that when I start, actually, let me get the casing first. So add numbers, open paren, and actually, let me back up one more time. Add numbers. There we go. So it's saying that we need to specify an integer for num A. I don't know, we could use 4.
Okay.
For num B, we could use
25.
The number 25. Closing paren, we have our other closing paren from the right line.
Right.
So now we're ready to go.
Okay.
So we'll execute, and we get a number 29, which is indeed correct. 4 plus 25 is 29.
Sweet. It's working. Now this here was an example of a method that's returning something that's then being used by another method, console.writeLine. So let's do this real quick. Let's go ahead and close that, and let's take and create a quick variable, an integer variable, and put the results in that variable. Then turn around and write out that variable.
So make a new int called result, or even better, let's make an int called sum.
Okay.
And sum is equal to...
And then just cut and paste that out if you wanted to.
Oh, you mean this one, the add numbers?
Yeah. But you're almost there now, so go ahead and put it in.
I see you wanted to keep the exact same one we had. But just to duplicate the results, we had 4 for num A, we had 25 for num B. Close the paren, terminate.
Actually, I was just going to have you, after doing that, highlight, that next line, and just replace that with sum.
So we'll take out the call here, replace that with the sum, and looks good, so let's execute. And we get the 29. Same thing. But again, just showing a different way of using the result.
Yeah, and this is another way that we will use quite often. We actually are right here creating a variable called sum that can hold some data for us. It is of type integer, and we are initializing it as soon as we declare it, and we are initializing it with a call to the calculator's add numbers method, and we are sending the arguments 4 and 25. So 4 and 25 is then going into the num A and num B parameters. We then do a little bit of work with num A and B by adding them together and returning them back to the caller. So the caller of this was back over here in the program class. This was our caller right here. So the result was then put into sum because of our assignment operator, which we'll talk more about that later. So sum now holds that information. We drop down to the next line and we tell, hey, console, write out whatever is in sum, which is 29. And there you go. So that is a very, very brief look at methods. Okay, objects with methods. Methods is functionality that we are giving to the object to do a specific task. We can send information in, and we can get information back from it if we design it that way. So with that, what Logan's going to do now is go through and...
There's actually one thing I want to do really quick to this example. What I was talking about earlier, what I was going to go back to, was just a common pitfall to avoid when defining your parameters.
Sure.
In cases where you have multiple parameters, you have to define the type for every single parameter, even if it's the same as the parameter before it. For example, if you were just typing these out, let's say you were typing them quickly, and we're getting a little careless, where you would have num A, I want another parameter, comma, num b. That won't work. If we try to build identifier expected, and that's because we didn't specify the type for the second one. Even if it's the same type, we have to specify it again.
That's right. Okay, cool. So with that out of the way, we can go ahead and delete out the calculator class because it was just a temporary one.
So we can select it, right-click, delete, and there we go.
Now it's gone, and now over in Program, let's go ahead and remove all of that stuff out. Excellent. All right, now Logan is going to, again, go through and just set up the framework for every single method throughout this application.
All right. Well, let's begin with the Game Manager.
Okay.
So let's jump over to the Game Manager class, and of course we've already got our first method in place because we were using that to test last time. And now we need to move on to the rest of them, and again we've got them noted out here with comments. So let's start with Start Game. Start Game needs to be a public static method. Its return type is void, and we'll apply the bracket blocking. And that's it. We're just going to go through all of these classes really quickly and establish or define all of our methods. We're not going to code in what they do yet, just define what they are, what they return, what type of parameters.
And there's no reason for Start Game to take any information in. We're just going to say, hey, Game Manager, start the game, and that's what he's going to do.
Right. It's a simple task. It doesn't require any arguments. All right, end game. This will be a public static as well. Return type void, and we'll have our open and closing brackets, and there we have end game.
Okay.
The last thing we have is apply rules, and same thing here. Public static void apply rules. And that's really it for Game Manager.
Okay, Game Manager is now done. Moving on to Level.
Alright, the Level class. What do we have? We have two things. We have initialize and build level. Since we're inside a static class, again, these are going to be static. They're also going to be public because we need to call them from outside of level. So we have public, static, return type is void. We're not looking for any kind of return. We're just telling it to do something. And that takes care of initialize. And the only other thing we have inside of level is the build level itself. And this is going to be a private static because with the framework we have in mind, we're not building levels from anywhere other than the initialize.
Right.
We don't load levels afterwards, so as of yet there's no reason to call build level from outside of the level class.
Precisely.
So this will be defined as private.
Okay, and that's going to wrap
Almost.
up. What?
I don't have the return type.
Ah, very good, very good. Okay, so that's going to wrap up level. So next, let's go ahead and take a look at room. We've got quite a few in here too. Okay,
right.
This is where things will get interesting too.
All right, public methods. So it appears that we have both public methods and private methods we'll be dealing with. This one, technically, level should have been documented in the same manner, but oh well. As a matter of fact, we could go back at a later time and do just that. But let's begin with the public methods. The first one we have is describe. And this is going to be a public, let's see, give me 1 second while I search this. It's going to be a void because its job is to do the describing, not to prepare some text that is described.
And it's public because anybody can say, hey, room, tell me about yourself.
It's not static because room is not static. We're going to have lots of rooms. And describe takes in no arguments. It's very simple, or just simply telling it to tell about itself, not take anything in. Alright, moving on, we have show title, which again is going to be public and void. Its job is just to show the title held within room. Basically describe but with less information.
Okay.
Now we'll move on to get item. And this will be, again, public. It will be, this time we're going to specify a return type. Get item is going to return an item, hence the name get item. And it is going to take in a string parameter by the name of item name. Because get item's job is to take this text, that is item name, look through all of its items. If an item is found that with a name matching item name, it should return an item.
That's right.
Now, with this being the structure that we're running in, the idea is that this will build, even though it doesn't do anything. So we're going to have to specify a return type. If we try to build now, we're not returning anything yet. So I'm just going to, for now, return null. So don't return any item.
Okay.
Or basically return an item that is null. All right, moving on. We have our add exit. This is going to be a public void method. Add exit is going to need to take in a string for what direction this is.
Because we have the ability to say add north or add south. That's the directions we're looking at.
Right. And the reason we didn't make this a property, because thinking about it, if we think back to the properties lesson, it seems like, well, we have exits, there are properties, why don't we just access that list?
Mm-hmm.
Like we talked about when we were commenting all of these in, we need to handle exits in a special way. We don't want to have the ability to have the same duplicate exit. So
right.
That means we're going to make this a method so we can have some intelligent code inside of it.
Right.
But that's all we're going to add to it for now. Now we're going to move on to remove exit. So this is a public void remove exit, which will take in a string direction. And again, its job is the opposite of add exit. It's going to look for this direction. If it exists as a valid direction, remove it.
Right.
All right, next up is can exit. This is going to be a public bool because it's going to allow us to ask for an exit by name, so by string.
And it will return back a bool being true or false. Can we exit that way? Yes or no.
All right, that takes care of our public methods. And before we move on, I'm going to do one thing just to start giving us the ability to clean this up. I'm going to start with our regions.
Okay.
So we'll have a region for public methods. And we'll end our region. Because I could almost remove that comment now, since we have this as an entire region. Public item. I was just glancing at this because it has the... this might have actually been from before. Let me try building for a second. Oh, I see. Here's what I was doing. Before this had the blue underline indicating that there was some problem, and I saw the not all code paths return a value.
Gotcha.
I was like, I don't understand, it's returning. But we haven't finished coding in can exit.
Right.
That's a good point. Before we get too far away, it's good that we caught that here. Because in the same light with returning an item, we're returning a bool, which means we need to return something.
Right.
We don't have a real code in place, so our placeholder code is going to be return, well, let's default it to false.
Okay.
And with that, let me do a build so we can finish off the public section. And we have built successfully with only the warnings remaining.
Okay.
So to clean up the screen a little bit, I'm going to go ahead and collapse our public methods region, and we can move on to the private methods.
Sounds good.
All right, first method, get item list. That is going to be, of course, private. It is going to return a string, and it is not going to take any parameters in. Its job is to simply look at the item list, so this items list inside of the room, and generate a string, not really a string list, but a string that shows all of the items, and then return that string. This will be used when we're displaying what's in a room. And next we have get exit list, so a private string get exit list.
Yeah, just so that no one's confused here, if you remember when we were playing Hyperion while we were demonstrating it, each room we walked into, it said items in room, and it listed those. And it said directions that you can go, and it listed those. And this is what we're going to use for getting that and assembling that.
Exactly. Items in room, and
Access
then directions
basic.
you can go.
Yep.
All right, one last one. This is, of course, private, and it's going to return a string, and it's called get coordinates. And this is more of a debug procedure that we...
Yeah, so that while we're running around through our different rooms, we could have the coordinates echoed out to us if we wanted them.
Right, and because it's returning a string, it would make sense to maybe back in our describe. We could, in the case of a debug run through the game, we could add this into describe, and then we also get the coordinates along with everything else.
Precisely. Okay, very cool. So that is going to wrap up rooms, believe it or not. Let's see, where do we want to move on to next? Item?
Item doesn't have any methods within it.
Oh, that was loads of fun. So that takes us to player, which is our last big one.
Alright, jumping over to the player class. Alright, here we go. We've got, all of these are going to be public, and we're going to begin with move. So we're going to have public static, because we're within a static class, and it's going to be, or have a return type of void, and it's going to take in a direction that we're trying to move. And the direction is going to be passed as a string. Again, move's purpose is to take in whatever direction was typed by the player, move in that direction.
If we can move in that direction.
And otherwise we're not returning anything.
Right.
Alright, moving on to pickup item. This will be a public static void, so we're not returning anything. Now pickup item needs to take in a string, which is telling us what item to pick up. This will be item name.
Okay.
So very straightforward. Pick up an item based on said name. Now we've got drop item. Again, public static void drop item.
And it's going to take in a string item name.
Just like when pickup. It's kind of the opposite of pickup. Oops. New line, and then we block in our method.
Okay, now down to display inventory.
This will again be a public static void display inventory. We're not taking any parameters.
No, we just wanted to display the inventory.
Right, the only one inventory that we have. There's no reason to specify any parameter.
Precisely.
Alright, get current room will be public static, and it's going to return a room object, and it's going to not take in any parameters because we're already specifying which room? The current room. There's no reason to specify anything beyond that.
Basically, where the player is right now is our current room. Okay, very cool.
And one last method. This is the
get inventory item,
and it will be public static, and it will return an item because we are getting an item, so it makes sense to return an item object. And we're going to get the inventory item by name, so we're going to need to pass it a string item name. And that's it.
Alright, let's make sure everything is going to build just fine.
Alright, so quick build to project build, and I'm probably going to start using the F6 key here real soon, but just so you've seen it one last time, build solution, which has hotkey F6. And, because we've got a lot of things that are returning and we haven't placed our return values yet. So jump back up to the first error, which is the first thing within, as a matter of fact, this jumps back one. We weren't finished with room. The first error is actually back in the room class.
Oh, we left one out.
We've got left a few. We've got get item, all of our private methods that were returning strings.
Oh, that's right, because we were taking such care to watch after the public methods, not the private ones. That's not a problem.
For now, we're just going to return a blank string. So open quote, and then nothing in between it, then another quote.
All right, go ahead and copy that line, and we can just paste that down a couple of times in the other two. Okay, so that'll all compile much better now.
Now we need to jump. If I compile, we should have a few things in player. Get current room needs to return a room. We don't know which room we want to return, so we'll just have a null room be returned.
Okay.
And then in get inventory item,
same thing.
We can return a null item. And now if we build, good, now we build. We have our warnings, but we have all of our return types in place and working for player.
Fantastic.
Alright, moving on.
Alright.
Next we have the command processor.
Alright, couple in there to knock out.
Alright, first up is process command. This is going to be public. It's going to be static. And it is not going to return anything, so it is void. Now, process command does take in a command as a parameter. It's going to be of type string because, of course, we're going to be typing things into the game, so it needs to process strings. We're going to call this parameter line because we're going to be using this in conjunction with read line, so it makes sense that we're handing this lines of information.
Right.
And then we have our blocking, and we're done with process command. The other thing we have is show help, which will be a public static void
And
show
that's
help.
it.
And again, that's just to display the help screen, so nothing else needed here.
Very cool. So again, we can go ahead and make sure it builds.
Good idea. So we'll build, and yes,
All
build
good.
successful.
All right, so on over to the text buffer where we have just a couple.
All right, text buffer. First up is add. So this is going to be public, static, again, within a static class.
Void.
Add. Oop,
Yeah, void because it's not returning anything. We're simply adding.
And what are we adding to it? Well, we're going to add a string because we're adding some text to the buffer. So we take in some text as a string, and that takes care of add.
Okay.
Now on to display. We have our public, static, again, void, display. Now display isn't going to take anything in. Its job is just to take whatever we have collected in the buffer and display it.
Precisely.
All right.
Text utils.
Text utils has a few. We've got extract command. This is going to be public, it's going to be static, and it is going to return a string. And extract command, we are also going to take in a parameter, which is going to be another string called line. And the idea being here that we take in an entire line and return only the command portion of said line.
Let's go ahead and set a return in here too.
So we will return, and for now, blank string.
Okay.
Alright, we've got extract arguments, which will be public, static, string, extract arguments, and again, taking in a line parameter as of type string.
Okay.
And we'll get our return type in, so return blank string.
Okay, very nice, very nice.
Alright, last method within text utils, word wrap. Which will again be a public, static, string, word wrap. And now this one's going to have a string for the text that we're going to be word wrapping, as well as a second parameter. So we'll add a comma. This parameter will be of type int, and it will be a buffer width parameter.
And we'll explain that more a little bit later. Good enough for now.
And then we'll get our return. Only this return, we're not going to return blank. What we're actually going to do is we want to set it up. It would be very nice if we could have our code set up so that it is ready to use it, so that things like the text buffer actually use the word wrap method. But in order to make it so that it can work without having to code the entirety of word wrap, we're just going to pass through the text value. And we can do that by simply returning text without doing anything to it. So if we call word wrap, of course we'll have to specify some buffer width, but that's irrelevant because we don't use it yet. But we'll take our text and just give it back unchanged.
Right, so basically this acts at the time as a pass-through method. Okay, cool. So
another quick build. Everything is good. We could run to prove that. Everything is in fact good.
Very, very nice. Okay, well, got everything?
Oh wait, one left.
We got, is it a valid direction or not? As Logan now digs up, there we go.
In the direction struct, we have an is valid direction.
Right.
This will be public. It will be static.
And it will return true or false, so it's a bool.
And we need to take in a direction. So what direction are we asking? And this is our direction. And for now we're going to play this easy and always return
a false.
False, just to go with standard. If we end up actually using that for some reason, we might change it to true until we put it all in, but that keeps up with everything we've done so far.
Actually, go ahead and do that. Go ahead and change it to true. Can we move that direction? Sure, you can always move that way. We don't care. All right, beautiful. That is going to...
Yes.
Yep,
run.
it builds.
Yes. All right.
Whew, that's pretty much going to wrap this lesson up. I know there's a lot of stuff going on, not very exciting at the moment. I believe it's the next video things are really going to start to take off, where we start putting some true functionality into place. We've spent all of this time just preparing, just setting up a skeletal application, skeletal framework that we can then start plugging the meat into and making things happen. So hopefully by now you have just a light general idea of, well, what a method is, and that a method has a very particular structure that it's in. It has the ability to take in parameters, so we can send arguments to it, and then it can work on those pieces of data internally, and it can also send a return value back out to whoever called it. So that's pretty much what I wanted to show you guys, and that is going to wrap up this lesson. Thanks a lot.